Imagine a robot that doesn't just move like a human, but thinks like one too. Unitree's latest humanoid, the G1, has just been given what they're calling a robotic brain, and it's already performing tasks with shockingly human precision. This isn't sci-fi anymore. This is real, and today we're diving into this breakthrough, plus the latest jaw-dropping developments in AI and robotics. Welcome back to the channel where future tech meets reality. In this video, we'll explore how Unitree's G1 humanoid robot is pushing the boundaries of what machines can do, thanks to a revolutionary AI-powered control system called Adaptive Motion Optimization. But that's not all. We've got a roundup of the most exciting news in robotics and artificial intelligence, from robots learning through YouTube videos to machines that clean your house better than you do. So buckle up. The robotic revolution just took a giant leap forward. In recent days, robotics news has erupted. With ammo, Unitree's G1 humanoid can clean, pick up toys, open the fridge, and load the dishwasher like it's been there for years. Redesigned firefighting B2 robot dogs can send foam 200 feet with water cannons. Lenovo's TIE chat practicing humanoid Legion No. One answered business questions. Beijing stated that robots will compete in track, gymnastics, and football at the August World Humanoid Robot Sports Games at Olympic sites. Talk about it. Unitree G1 is famous in robots, but the ammo changed everything. The most advanced consumer-level humanoid real-time, whole-body control system may not be a marketing tagline. The one became a living robot, not just a brilliant machine. Most robots struggle with sophisticated movements because humanoids are hard to control. Flexibility and stability are difficult to balance due to nonlinear physics, contact dynamics, and 29 degrees of freedom. Traditional methods used inflexible control systems or motion capture data in static situations. Robots can mimic human movement, but not real-time correction. Ammo changes everything. AMO construction varies. Robots move and adapt using reinforcement learning and trajectory optimization. Sim-to-real learning simulates millions of motion tests to let the robot make mistakes without breaking. Lifting, reaching high shelves, rotating its body, squatting low, and extending laterally without losing balance are learnt. Lessons become kitchen habits. AMO activates when G1 bends to pick up a toy or delicately balances a bottle on a shelf. The robot's legs, chest, waist, and other sections are controlled inside. Timely responses to environmental changes and unanticipated inputs. In VR teleoperation mode, it shadows your movements. Amazingly, it doesn't freeze when released. It continues. It knows the aim and executes flawlessly from human to autonomy. Introducing AMO's hybrid motion synthesis pipeline. Motion capture data's human-like arm movements and sampled torso commands produce novel body activities. Robots generalize, not copy. The G1 has more yaw, pitch, roll, and height control than earlier systems. No waist motor, just tilts the upper body. Instead, it bends knees, moves legs, and uses posture to reach angles past robots couldn't. After extensive development, G1 can handle new requests and scenarios. More than trained, it stretches, crouches, or turns. One test had it lift floor-level baskets from both sides and place them on an eye-level shelf. Fully coordinated crouching, twisting, reaching, and placing was once science fiction. This is classic AMO. AMO was thoroughly compared to previous controls. It tracked yaw, pitch, roll, and base height. In unfamiliar territory, AMO tracked well. That shows the robot adapted precisely, not guessing. It gracefully spun 90 degrees and threw trash precisely. In another position, it positioned its torso, put its hand through the loop, and lifted and dropped a paper bag without moving. System-wide teleoperation and task-specific autonomy were applied. Even more impressive is how AMO builds such behavior. A two-stage learning framework is used throughout training. Teacher policies have access to all the ideal data, and student policies learn from it in a more constrained arrangement, mimicking the robot's real-world experience. This method makes the final system reliable without perfect conditions. Not your typical walking bot. The G1 with AMO plans, adjusts, and executes difficult tasks that most robots struggle with. It moves, crouches, twists, walks, and balances, with 29 joints throughout its body. AMO drives it without that odd mechanical stiffness. Motion is fluid, purposeful, and human-like. This is humanoid robotics' future. Mobility, full-body dexterity, and response enable real-world deployment. Unity continued. Their four-legged firefighting robot dog, a modified B2 robot, is for emergencies. This firefighting variant has a 40-liter per second water or foam cannon that can shoot 60 meters out. It's intense. With 170% better joints than the ordinary model, it can climb 15-inch obstacles and manage 45-degree steep stairs, ideal for chaos and shattered buildings. It goes beyond muscle. The B2 firefighting dog has tech, live video, LiDAR sensors, and communication gear to update human teams. The heat-resistant cooling sprinkler system and swappable batteries won't affect its waterproofing. Designed to go where humans can't. Toxic zones, collapsed structures, and no visibility. It maps, finds fires, carries modules, and aids rescues. Let's move from reality to business. Lenovo is serious about their humanoid robot entry. At Tech World 2025 in Shanghai, they introduced Xiang No-Won, a Silicon employee. Not just a press release. They had it do Tai Chi on stage, not only walking or standing. Actual, slow, balanced martial arts live. In real time, the robot pulled data from Lenovo's systems and answered Q&A questions like a rep. 3 smart structures power this robot. It can comprehend and communicate between devices, access public and private ecosystem data, and do complex tasks autonomously. Lenovo's secure hybrid architecture, device, edge, cloud, and network power everything. Cross-platform data collection, processing, and AI model training are seamless. Lenovo isn't lying. Practical applications are planned. Elder care and healthcare will soon use this robot. It will compete in the Beijing Humanoid Robot Sports Games in August. Beijing's Bird's Nest and Ice Ribbon Olympic sites host the event August 15 to 17. This isn't a trick. 11 human sports will be replicated by humanoids. Athletics, football, gymnastics, etc. Roboticists and athletes created human-like events. The objective is clear. Improve mechanical structure and motion algorithms with pressure testing. China's second big robot sports tournament this year. April marked the first humanoid half marathon. 20 robots ran for 2 hours, and Qiankong Ultra won after 2:40. It went beyond endurance. The bar for stability, safety, and real-world readiness in complex situations was high. Several companies' robots were tested outside. Please return to the research lab while this is public. Other robots cause ripples. China's P&D Robotics invented Atom. Atom walks differently. Like a human, it changes its stride, balance, and pace on uneven ground. The patented reinforcement learning technology and imitation learning allow this. Atom has been developed and modified almost everywhere since mid-2023. Its modular actuators and strengthened legs and feet make it sturdy and versatile. Full-body motion and real-time controls are in the Intel i7 full-stack system. The 25 force-controlled QDD actuator legs create 360 N torque. Standing 1.6 meters tall and weighing 60 kilograms, the robot has 5 arms and 3 degrees of movement. Hosting will be EU Robotics and the World Federation of Engineering Organizations. Humanoid robots are the main focus this time, not just as fascinating, but as scalable rescue and healthcare solutions. This is heading somewhere. Moving past demo, not futuristic or experimental, but useful. What would you do with a G1 or Atom home robot first? After $100 million, Phantom's next upgrade may be examined. We're living in a time where robots don't just follow commands. They learn, adapt, and evolve. The Unitree G1 might just be the blueprint for the AI companions of tomorrow. So what do you think? Are we on the brink of a robot-powered future, or should we be worried about what's coming next? If you enjoyed this deep dive, give us a thumbs up, subscribe for more future tech content, and hit that bell so you don't miss what's coming next. Got thoughts, fears, or questions about AI and robots? Drop them in the comments. We're reading everyone. Until next time, stay curious and stay human.